All right, let's dive right into this explainer. We spend so much time looking at all the surface level growth around us, the sprawling new subdivisions, the busy roads, that it's incredibly easy to completely forget about the lifeblood moving quietly right beneath our feet. Today, we're taking a deep dive into the local groundwater situation, pulling directly from detailed county assessments, hydrological data, and historical records from Loudoun County, Virginia.
So, with all this rapid development happening up on the surface, we really have to stop and ask what is actually happening to that vital groundwater supply hidden below us? In regions heavily reliant on private wells, like Western Loudoun, the health of this invisible resource is literally a make or break issue for farmers, rural businesses, and tens of thousands of residents. But as you can imagine, there are a ton of myths swirling around about where this water actually comes from, who is taking the lion's share, and why folks are suddenly having to drill their wells deeper and deeper.
Before we get into the weeds, let's quickly define the water table. Think of it as the natural fill line for our underground water storage. Now, according to the county's hydrogeological reports, we aren't talking about some massive underground lake here. It's simply the elevation point where the dirt and rock become completely saturated with water. When we talk about a healthy groundwater supply, we're really just talking about maintaining that specific fill line. If we're sucking water out faster than nature can rain it back down, well, that line drops.
Okay, part one, the invisible water sponge. Let's uncover the geological plumbing.
To really grasp what's going on, we have to look underground. The region's geological plumbing fundamentally dictates how much water is actually available to anyone living above it. It helps to think of the geology here as a two-part system. First, you have the shallow soil, which acts like a giant sponge catching and holding rainwater. Then, beneath that, you have deep, fractured bedrock that acts almost like transmission pipes. That shallow soil sponge is called saprolite, or overburden, and it usually ranges from just a few feet to maybe 40 feet deep. That is our actual water reservoir. Below it is the solid, fractured, metamorphic rock, mostly granite. And here's the catch. The granite itself doesn't actually hold water. It just has these narrow cracks that allow the water to move around.
Picture the journey of a single raindrop. It falls, soaks into that shallow soil sponge, filters down into the deep bedrock pipes, and is eventually sucked back up to the surface by a well. But if there's a prolonged drought, that shallow soil sponge dries out. It loses its water content, meaning it absolutely cannot recharge the deeper bedrock fractures. And if those deep fractures dry up, well, the wells that intercept them, which usually sit anywhere from 150 to 600 feet below ground, are just going to go dry. It's that simple.
Moving on to part two, who uses the groundwater? Or, as I like to think of it, poking straws into the sponge. Back up on the surface, it's pretty easy to look around and just assume there's plenty of water for everyone. But who is actually sticking their straws into this underground sponge? Well, check out this number, 23,000. That is staggering. There are over 23,000 residential private wells actively pumping water right now in the county. Every single one of those is a straw pulling directly from that delicate, interconnected system we just talked about. And every time a brand new well is drilled, it creates a cone of depression, basically pulling down the water table around it, which directly interferes with all the neighboring wells. And here's the real kicker from the county's data. 90% of those residential wells are packed tightly together, usually within just 550 feet of another well. They are all sharing the exact same limited water source as the region's 1,332 farms and the rural towns. When you have subdivisions clustered this closely together, all drawing from a fractured bedrock system that already has incredibly limited storage capacity, they are inevitably going to impact each other. And remember, we're also talking about agricultural users who are the backbone of a $50 million local farming economy. They are relying on this exact same fragile system. All right, part three. Do data centers drain it? Let's address the elephant in the room. We literally cannot talk about water in this region without pivoting to the most massive visible structures around, the data centers. Loudoun County is known globally for its massive data center alley. So, when locals see their private wells sputtering and going dry, it's completely natural to point a finger at the biggest new buildings in town. I mean, they're gigantic, so they must be super thirsty, right? There is a really pervasive local myth that these tech giants are the ones sucking the underground sponge completely dry. So let's look at the facts. Do they actually use the groundwater? The definitive answer, pulled straight from the county's own official FAQ, is a massive, resounding no. The data lays it out clearly. Currently, all data centers in the county are connected to public water systems. They are using either potable drinking water or reclaimed water provided directly by the municipal utility. So the crucial takeaway here is this stark contrast. It's really a tale of two entirely different systems. The data centers over in eastern Loudoun operate on public surface water drawn from the Potomac River, or they use reclaimed water. Meanwhile, the rural West relies entirely on private underground wells. They're operating on two completely different water ledgers. The data centers in the east are simply not pulling from the fractured bedrock aquifer that supplies the farms and the subdivisions out west. Which brings us to part 4, the real groundwater threats. If not the data centers, what is actually depleting the aquifer? So, if we can't blame the tech giants, what is the actual problem? What's causing the water table to drop so low that people are having to literally truck in water for their livestock? Take a look at this timeline because honestly, it shows a terrifying trend. As the shallow water table drops, drillers have been forced to dig increasingly deeper over the decades just to find a reliable supply. Back in 1976, local experts noted you only had to go down maybe 100 to 150 feet to hit good water. Fast forward to the 1980s and early 2000s, and studies show the average well depth had plunged to between 300 and 500 feet. Today, some new wells are being drilled down to nearly 1,000 feet. And think back to our plumbing analogy from earlier. Drilling deeper into the bedrock does not mean you're finding a bigger, better sponge. You are just hunting for deeper, far less reliable cracks in the stone. The first real proven threat is climate change. Hotter, much more frequent droughts and massive rainfall deficits mean our underground soil sponge just isn't getting recharged. The recent data out of Dulles Airport is sobering. In 2023, the area was short by 8.5 inches of rain. In 2024, that deficit actually grew to 9.2 inches. As the climate warms up, we just aren't getting those slow, steady rains that easily percolate down into the ground. Instead, we get these sudden, massive downpours where the water just instantly runs off downstream, way before it ever has a chance to soak into our shallow soil sponge. And the second major threat is the surface development we talked about earlier. With 9,000 new wells drilled since the year 2000, all those clustered residential straws are creating localized zones where the water table has literally plummeted by up to 40 feet. The county's analysis comparing pre-2000 and post-2000 data reveals widespread areas of significant decline. We aren't just talking about one or two unlucky homeowners here. The health department has recorded hundreds of completely dry holes in replacement wells over the years. The hard truth is, we are simply pulling water out way faster than the changing climate can put it back in. So, I want to leave you with this thought to mull over. Knowing what actually threatens the hidden world beneath our feet, what steps can we realistically take to preserve this essential resource before the sponge goes completely dry? The data makes it incredibly clear. Climate-driven droughts and the sheer density of residential wells are putting unprecedented strain on these fragile, fractured aquifers. Understanding this hidden reality isn't just interesting trivia. It's the absolutely crucial first step toward making sure there's enough water left for all of us in the future.